All right, so we're going to finish up this section. We had talked last about like how to break apart these complex numbers, how to pull out that I. We talked about solving equations by like setting the real parts equal to each other and the imaginary parts equal to each other. We're going to do a little bit of review first, just to kind of pull some of that back from the last time we talked about this. And then we are going to add in just a couple of new pieces today. So first thing I want to do is just go back over how do we pull out the imaginary number from these terms. So for the first one, we have 2 times the square root of -3. Now the -3, you can't really reduce that at all. You can just pull out the I. So if you needed to, like we did before, you could rewrite it. So it's like 2 times the square root of 3 times the square root of -1. So the square root of -1 becomes an I, so you'd have 2I and then square root of 3. Once you get really comfortable with complex numbers, if you understand that you can just pull the I out and get rid of that negative sign, you don't have to show me like each individual step. So for number 2, what would be the square root of -4? Okay. So what is the square root of 4? 2. So we'd have 5 times 2 times an I. So what's the final answer? Good, 10I. Okay, you guys try number 3 there. Try to simplify that one. So if I break it apart like this first, what is a perfect square that can go into 75? Good, so break it down to 25 times 3, and then that square root of -1 becomes your I. So what's the square root of 25? 5. So 5 is going to come out, then the I, and then square root of 3 stays. The next thing that we did the last time, like when we were doing the first half of this, is we solved equations using this same process. The only difference here is that you're going to see it equal to 0. And so we have to rewrite it first so that we get our variable alone. And then we square root and we do the same things that we were just doing. We try to break it apart if we can, pull out the I when you've got that negative in there. So for this first one, I have x squared plus 25 equals 0. What should I do to get x squared by itself? Okay, so subtract 25. So now it says x squared equals -25. Then what do you guys do? So root both sides, good. So what's the square root of 25? 5. And that negative is going to come out as a I. So make sure you have 5I. Okay. Number 2. First thing I would do is subtract the 56. So now it says 2x squared equals -56. Then what do you have to do before you square root? Divide by 2. So we have x squared equals negative 56 divided by 2 and be negative 28. Now I square root both sides. So we have x equals, finding this part, it's square root of 28 times the square root of negative 1. So what's a perfect square that can go into 28? 7 times 4. So 4 is the perfect square. So 4 times 7, and then times I. So x is going to equal, what's my final answer going to say? So 2i squared root of 7. Okay, so solving those equations, like we did last time, is going to bring us into one of the new pieces I'm going to throw at you guys today. But it's not going to be all brand new. Like everything that I'm going to do with you guys now is all things that you've already done. The only difference is that we're going to have negatives underneath the square root sign. So we're kind of combining what we've done in the past with what we've been doing recently. So when we talked about completing the square, we did that whole process of taking like half of our b term, squaring it, adding it to both sides of our equation, and then solving. Now when you guys did completing the square the first time, you only have positive answers that you were working with. So the difference now is that they're going to throw in negatives at you. But we know how to handle it now because we've been dealing with all these complex numbers this entire time, this whole section. So if you get a negative, you just do exactly what we've been doing. When you square root it and then you have a negative underneath there, you have to pull out the I and then work with the number just like we've been working with the number today and what we did previously. So when you have something like this, x squared plus 6x plus 34, the first thing that we want to do is think of this as being equal to 0. And if you don't remember, we like to have the regular number on the other side of the equal sign. So I want to move this 34 to the other side. This is that, I said when we talked about completing the square, this is kind of like the only case that it's a little bit different and that we don't want it to be all on the same side of the equal sign. We want that number to be on the other side. It's the only time that you see that happen. So instead of saying this, I'm going to rewrite it so it says x squared plus 6x equals, if I move 34 over, it would become negative 34. So step 1 is to take half of our b term. Your b is that 6 because it's sitting in front of the x. So we're going to do 1/2 of 6, which is 3. Step 2 is to square that number. So we take 3 squared, and we get 9. Next, using the equation that we rewrote up here, so we have x squared plus 6x. This is when we drew in those blanks. So plus a blank equals negative 34, and then plus another blank. Okay, the number that goes in those blanks, remember, is what you got in step 2. So that 9, that's what you drop in to those blanks on each side. So plus 9 there. On the left side, this is when we had to rewrite it as something squared. Since it's just x squared, we go ahead and just put an x in there. And remember I said the shortcut way is to look at that number you got from step 1, which is that 3. That's what goes in. So it's x plus 3 squared. Because you're looking for the one number that times itself, you get a 9. Added to itself, you get a 6. So 3 times 3 is 9. 3 plus 3 is 6. Now, on the other side, negative 34 plus 9 is going to be negative 25. So everything I've done so far is nothing new. We've done completing the square. Now we've got this equation. We're going to solve it like we've been solving those ones previously, except I have a negative 25. So, because I see that and I know that my next step is going to be to square root both sides, I know I'm going to have to deal with an I, because I've got a negative underneath the radical. So if I square root on both sides here, Remember that on the left side, it's just going to say x plus 3 now. Because the square root and that squared cancel each other out. And the square root of negative 25, 25 is a nice perfect square number, so that's 5. But then you're going to have I. Now remember, technically, this is plus minus 5i. That only comes in because I'm going to still have to solve for x here. So I got to move that plus 3. And it's not just going to be 3 plus 5i, but it's also 3 minus 5i too. Because when we square root something, there's the positive and there's the negative piece to it. So I'm going to finish this up by subtracting 3. And I'm going to write my final answer here. It's going to say x equals that negative 3. We always write the number first. Plus or minus 5i. And you guys are going to leave it here. You can't simplify it beyond that point anyway, because it's an imaginary number. So there's like 5i represents a negative square root. It doesn't represent an actual number like 10 or something like that. So we can't take negative 3 plus or minus that anymore. We have to leave it here. Okay, so there's another one here I want you guys to try. We'll get it started by rewriting it first. So I want to set this equal to 0, and then I want to move my 45 over to the other side. So I want it to say x squared minus 12x equals negative 45. So your first 3 steps, you're supposed to take half of your b, and you're supposed to square that number. And then I want to see you guys rewrite the equation. I'm going to walk through these first couple of steps if you're stuck somewhere here. So what's your b number? Yeah, so we're going to take half of negative 12, which is negative 6. That's the number that you need to square. So you should have gotten a positive 36 for step 2. Remember I said previously when we were doing complete and square, you should always, always, always get a positive number for step number 2. Because if it's a positive times a positive or a negative times a negative, it's always a positive answer. Now 36 gets dropped into those blanks. So how do I write the left side as something squared? X, and then what's the number that goes in? Good, negative 6. So it's always that number from step 1. So x minus 6 squared. What's negative 45 plus 36? negative 9, right? Okay, so if you got stuck somewhere, now we've got it all right here. I want you guys, if you haven't solved it yet, finish it up and solve this problem. All right, so you should have square rooted both sides. We're left with x minus 6 on the left side. How do we rewrite the square root of negative 9? Good. Plus or minus 3i. And then what's the last thing we needed to do? Good. Add 6. So to write that as an answer, put the number piece first, so 6 plus or minus 3i. So I had mentioned previously when we were working through the first half of this section that all complex numbers are written in this form. You've got like a regular number and then your complex number piece. So it's always like 5 plus or minus or plus or just minus then the imaginary part. So 2i or 5i or minus 6i or something like that. So that gets us into the second new thing I'm going to throw you guys today. We're going to talk about something called the conjugate. So you may have talked about conjugates possibly in geometry when you were going over just like square roots. And especially when you're working with some triangles, there's some square roots that are involved. So the conjugate is all you do is switch a sign. You switch a plus sign to a minus sign or a minus sign to a plus sign. And that sign is in between your number pieces. So a lot of times, like with square roots, it would be the number sitting in front of the square root sign. So, for example, a plus bi would be an example of a complex number. A is like the normal piece, like 2, and the bi is the complex piece, the one that has the imaginary number attached. So the conjugate is, instead of plus sign, you change it to minus sign. So it's a minus bi. That's all there is to a conjugate, is just flipping that sign. Don't make it harder than it needs to be. Okay, so when I'm asking you to find the conjugate, if I give you something that says 2 plus 3i, you just write 2 minus 3i. And that's it. You just switch that sign. Now, number 2, if you have negative 7 minus 6i, do not change the negative 7. The only sign that you change is the 1 in the middle. So like up here, all I did is I changed this plus sign to a minus sign. So all I want to see you guys change in number 2 is this minus sign. So it's going to say negative 7 plus 6i. Simple enough, right? It's not too hard. You're just changing a sign. Now, do you guys remember what I said is technically sitting in front of this 3i? Zero. Yeah, so 0 is in front of that 3i. So, like, there's no regular number, there's no real number piece to this that's written. But we had talked a little bit about this case on Friday, that this would be 0 plus 3i, because 3i is positive. Now, if it was a negative 3i, it would be 0 minus 3i then. So the conjugate would be to switch that sign in the middle, so it says 0 minus 3i, which is the same thing as just negative 3i. So do you need to put the 0 in front? Not really. You can just change the sign so that it's, instead of positive 3i, it's negative 3i. But to understand, like, how that happens, it might be helpful to have that 0 in front as just kind of holding that place of that regular number. All right, on the next page, it kind of goes into when you're solving a quadratic equation, if one of the solutions is a complex number, then the other solution also needs to be a complex number. You can't have a situation with a quadratic equation where only one of the answers is complex and the other one's regular. Because if we think back again to like the cases that we talked about, so I'm just going to draw like you guys little pictures here. If we had our 3 cases. We had one of them where it crosses that x-axis twice, so those are 2 real numbers. We had the case where it only crossed once, so that's 1. And then we had the case where it doesn't cross at all. Okay, and that's how we got the complex. There's no way for me to draw a quadratic equation where one side would not touch and the other side would. It would no longer look like a quadratic equation. It would be kind of a weird looking graph. Okay, if you wanted to imagine what that would look like, you'd be like one side goes up like this, the other side would have to dip like way down and then go up. That no longer looks like a quadratic. Okay, it's completely different. So if you have one answer that's complex, they both have to be complex. That's why we're talking about the conjugates, because if you have one of them, you should be able to find the other one by just switching the sign. Now, if they switch the way that it's written, like this one has the imaginary piece first, and then -7. What I would do to get you started so that you can find the conjugate is write it in the correct form first. Put the number and then the imaginary unit. Just make sure you watch your signs on this one, because it's a -7, so that needs to come first. 3i is positive because there's no sign in front of 3i. So this is really -7 plus 3i. So what would be the conjugate of this? Yeah, -7 minus 3i. What's the conjugate for number 2? Sure, positive 8i. All right, last thing that we're going to do, this is also review from what we did last week. Solving these equations again. Set your real pieces equal to each other and your imaginary pieces equal to each other. So 3x is the same thing as 6. Like those are both the real pieces. So I'm going to set 3x equal to 6. I would divide both sides by 3. So I get x equals 2. Then I have this -5i and this -10y. So I had said on Friday when we went over these for the first time, they both have the i's. Those i's are technically going to cancel each other off, so you don't really need to bring them along if you don't want to. You can just grab that -5 instead of equal to that -10y. You can drop the i's off right away. Then we would divide both sides by -10. So I have a -5 over a -10, which is going to reduce to a positive 1/2. There's my y value. So for this last one, what am I going to set -8 equal to on the other side? The 5x, right? So -8 equals 5x. And how would you guys solve that? I'm going to leave it as a fraction, even though it's improper. I'm going to leave it as -8 over 5. Okay, so the other pieces that are left, you've got a 6yi and then a -I square root of 6. All they've done is they've switched the I around on the second side. They put the I in front of the square root sign because that's normally where we would see it. Just drop those i's off of the problem. So on the left side you have 6y, And on the right side, it's negative square root of 6. Then you're going to divide by 6. And again, I'm just going to leave this fraction alone. So it's the negative square root of 6 over 6. You cannot reduce that. Okay, if something is underneath the square root sign and the other term is not, they're different. It's like trying to combine an x and a y together. You just can't. So think of that square root sign as kind of acting like a variable. It's changing it from the 6, and you cannot reduce that to a 1. So I don't want you guys to think that you can do that, because you can't. Okay?